Hey Dragons, this is a quick review of parallel and perpendicular lines and a couple of homework gimmies. So remember that parallel lines have the same slope and different y-intercepts. Here's an example of parallel lines. Notice that this is in the form of y equals mx plus b. Y equals mx plus b, slope-intercept form. You can always identify your slope. So if you notice in both of these, right here we have a slope of 3. The y-intercepts, the b's, are different. So put them in your calculator, you're going to have two lines that are parallel. They will not cross each other. They have the same rise and same run. Perpendicular lines, lines that cross at a 90-degree angle. They have opposite reciprocals. Here's an example of a pair of perpendicular lines. Notice that once again these are in slope-intercept form. Y equals mx plus b. We can look at the slopes easily. This is a positive 2/3, and this is a negative 3/2. So you notice that the signs are opposites. One is positive, one is negative. And you notice that the reciprocal is when you take a fraction and you exchange the top and the bottom, the numerator and the denominator. So 2 that was on the top, 3 on the bottom, they switch places. 3 is now on the top, and 2 is on the bottom. That's my denominator. Okay, so we're going to keep that in mind as we go through the problems. Okay, now I've put together just a quick kind of flow chart here on how to do these problems. The first thing you need to do is identify the slope of the line that you're given. What is your slope? Got to know the slope. Then you ask yourself, are you going to try to be parallel or perpendicular to it? If you want to be parallel to it, you're going to use the same slope as the given line. If you want to be perpendicular, you got to modify the slope. You got to use the opposite reciprocal as the slope. Once you figure out what slope you're going to use, take the given point in the problem, and you will be given a point to go through. Go to your point slope formula. Remember, that's a great place to start. Throw your numbers in, throw your slope in, and solve for y, and you have your answer. Here we go. This is number 3. We want to go through this point, negative 3, 4, and we want to be parallel. Okay, so you remember, parallel. We're going to use the same slope. So is this in slope-intercept form? No. Close. All I got to do is divide everything by 3. So I get y is equal to 2/3 x. 3 divided by 3 is 1. So what's my slope? My slope is the coefficient of x 2/3. Okay, so parallel. Remember, parallel. Do we use that slope, or do we have to change it or modify it? Well, parallel, we're going to use the same slope. So we're going to use that. We're going to use the points that we're given, we want to go through. And where's a great place to start? Yeah, that point slope formula. So now it's just number crunching time. Here we go. Y minus, what's my y value? Y's minus y's. 4 is your only y value. Is equal to your slope. We're going to use 2/3. And then the x's are in prison in the parentheses. X minus an x value is a negative 3. Double signs, this is really x plus 3. So all you got to do is distribute and add 4. So if we distribute, we get 2/3 x. 2/3 of 3 is 2. And over here, all I got to do is get rid of that minus 4 by adding 4 to both sides. And here's your answer. Okay? So the question is, are these two guys, the original equation and the one that we wanted to go through point negative 3, 4, are they parallel? Well, I just happen to have these guys loaded up and ready to go on my calculator. So this is the original equation, solve for y, and this is the one I just put together. So if I hit graph, or do a quick check, are they going to be parallel? Well, there's one, and there's the other. Look like a pair of railroad tracks. They're not going to cross each other. There we go. But how do I know that it goes through negative 3, 4? Well, go to your table. And look at your second equation. Remember, y sub 2, that's your second equation. And check for this. Do I have negative 3, 4? Yes, I do. So my equation's right. That's problem number 3. One more, let's do a perpendicular one. Let's go do number 8. We want to go through negative 4, 1, and we want to be perpendicular to 4x plus 7y equals 6. You know what to do first? You need to solve for y, because that's how I find my slope. So we have to identify the slope, which means you got to solve for y. So I'm going to subtract 4x from both sides, forming a 0 pair and leaving 7y is equal to negative 4x plus 6. And then we'll divide by 7. And hopefully you can see by now that this is why I'm a big fraction fan, because all I got to do is keep these fractions. I don't have to worry about what decimal they are. I don't need a calculator, don't need anything. So my slope is what? It's negative 4/7. Now the question you need to ask yourself, do you use that one or do you need to modify it? Well, we want to be perpendicular. So you remember what we do? We identify the given slope. That's a negative 4/7, but we want to be perpendicular. So the slope we have to use, we've got to take the opposite of a negative, so I've got to use a positive, and I got to flip this guy over. So instead of using 4/7, I've got to use 7/4. So what I'm going to do is I'm going to use not a negative, but a positive. That's an opposite. And then the reciprocal, I've got to flip these guys over. So I'm going to use a positive 7/4. That's the slope I'm going to use. I needed this so that I knew what to flip and what to take the opposite of. But now I'm going to go back to my old reliable point slope equation and use this point right there. Okay, so y minus what? What's my y value? My y value is a 1. That's the only y. What slope am I going to use? No, not the same one as the given line. I've got to modify it because I want to be perpendicular. I'm going to use a positive 7/4. And what's my x value? My x value is a negative 4. Again, we got double signs, so we know that subtracting a negative is really adding a positive. All right, so distribute a 7/4, 7/4x. The 4's cancel, leaving me a 7. And all I got to do now is add 1 to both sides. And so my answer, if I just kind of hop down here a little bit, I ran out of room, is y equals 7/4x, and if I combine those, plus 8. So the question becomes, is my original equation, which is right over here, which I'm pointing at, is this my original equation, and the one I've just created, are they perpendicular? Do they form a right angle? And does the second line go through this point? Well, let's see what we got here. Oh, wow, convenient. I looked at my calculator, and here are the two equations already set up, ready to go. All right, so remember when you check perpendicular on this, what you need to do is you need to press zoom and then 5. Otherwise, it's going to look all not perpendicular. So if I do this one right here and just press it, I don't know. This one kind of looks, if we rotate it right there, that really doesn't look like a right angle, does it? Okay, but look what happens when I hit zoom 5. Zoom and then 5. It's going to clean it up a little bit. I don't know why they can't fix it to begin with, but if you notice right there, that looks like I can put a little box in the angle, and that would be a 90-degree angle. Okay, double check to see that the second equation goes through negative 4, 1. The second equation does go through negative 4, 1. You did it right. Good luck on the others.